Hello students, now let us come to Chinese remainder. I think it is clear on the theorems on linear concurrence and its problem, how to solve us or how to find the solution of linear concurrence. Now we come to Chinese remainder theorem, which is again an important theorem. So here what does it state? It says like let m1, m2, comma dash mr be are positive integers. They are all positive integers that are relatively prime in pairs. Relatively prime in pairs mean you take any two of this m1, m2 or in general mi, mj for I different from j, their GCD must be equal to 1. And let a1, a2 dash dash ar be any r integers, they can be positive or negative. Then the system x concurrent to a1 mod m1, x concurrent to a2 mod m2 dash dash x concurrent to ar mod mr will have a common solution. And if x naught is one such common solution of this, then another solution, then x naught plus km for some integer k is also a solution, where m here stands for the product of all these are positive integers m1, m2 dash dash mr. So obviously because they are relatively prime, m1, m2 they are relatively prime in pairs, means that their LCM will be equal to m, that is the product LCM of all this. LCM will be equal to of m1, m2 dash dash mr is nothing but their product, that is m1 into m2 dash dash into mr. So by relatively prime, again we meant here the GCD of mi and mg will be equal to 1 for I different from j. Say GCD of m1 with m2 will be equal to 1, GCD of m1 with m3 and so on. So therefore the GCD of m by mj with mj again will be equal to 1 for j different, for j varies from 1 to r. Why? Because m by mj for if you take in particular j is equal to 1, it implies that m by m1, what is m here is the product of these r positive integers m1, m2 dash dash mr divided by m1. So m1, m2 will get cancelled. So this implies that this will be equal to m2, m3 dash dash into mr again, which is the product, which is an integer. So since GCD of m and mj with mj is equal to 1, so by the one of the properties of GCD, if G is equal to GCD of A and B, then there exists R and S, such that G here can be expressed as a linear combination of A and B, that is AR plus MS. So similarly here the GCD of M by MJ and MJ is equal to 1. So there exists BJ and RJ such belong to set such that, for each J belong to set, okay, such that this m by mj and mj or 1 can be expressed as a linear combination of m by mj and mj, that is m by mj into bj plus mj into rj will be equal to 1. So this implies that m by mj into bj is equal, you bring this minus mj rj to the right hand side, so it will become 1 minus mj rj, or you can write this as same as 1 plus mj into minus rj. So this implies that m by mj into bj will be concurrent modulo mj. Again, from the definition of concurrence and a relation between concurrence and divisibility, we have A concurrent to B mod M if and if M divides A minus B, if and if A minus B is a multiple of M, that is Mk for some K belong to set, if and only if A is equal to, bring this B to the right hand side, become B plus Mk. So again from here to here, this is if and only if statement. So we have M by Mj into Bj is concurrent to 1 mod Mj using this relation between concurrence and modulo. Now clearly m by mj will be concurrent to 0 modulo mi for I different from j, means if I is different, for in particular if you take for I is equal to 1 and j is equal to 2, means that I and j they are distinct, then m by m1 will be equal to m2, m3, because m1 as you can see here will get cancelled, so it remain as product of m2, m3 dash dash mr. Clearly this is concurrent to 0 mod m. Concurrent means because this is a product of m2, so when you divide it by m2, so it means that the remainder will be equal to 0. So therefore m by mj in general, m by mj, or we can say here m by m1 is concurrent to 0 mod m2 for I different from j. In general we have m by mj is concurrent to 0 mod mi. So this, now you multiply this concurrent here by bj. So this implies that m by mj into bj is concurrent to 0 mod mi for I distinct from j. Name this as equation 2. And what is equation 1? Equation 1 is m by mj into bj is concurrent to 1 mod mj. So with the help of this, we are going to find out the solution of this system of linear concurrence, x concurrent to a1, x concurrent to a2, and so on. So from 1, it implies that m by mj into bj aj is concurrent to aj mod mj. So you multiply this equation 1 by one of the properties of concurrence. You multiply on both sides of this by aj. So you have m by mj into bj aj is concurrent to aj mod mj. Similarly, equation 2, you multiply it by aj. So m by mj into bj into aj will be concurrent to 0, because anything multiplied by 0 will become 0. So therefore 2 implies m by mj into bj aj is concurrent to 0 mod mi for I distinct from j. Now consider x naught equal to m by m1 into b1 a1 plus m by m2 into b2 a2 dash mr by m by mr into br ar, which is equal to summation of m by mj into bj aj, where j varies from 1 to r. Now what we need to show is that this, where j varies from 1 to r, what we need to show that this x naught is a common solution of the system of linear concurrence x concurrent to a1, x concurrent to a2 dash x concurrent to ar mod mr. So let us fix this I. Okay. Then x naught here will be equal to summation, as we can see here, m by mj bj aj, j varies from 1 to r. Clearly this will be concurrent to, this whole thing will be concurrent to m by mi into biai mod mi, because m by mj is concurrent to 0 mod mi from equation 2 for I different from, we have m by mj into bj aj is concurrent to 0 mod mi for I distinct from j. So as you can see here, m1, m2, b2 dash. So if you take mi, because we are fixing I, so there will be somewhere here this x naught here will be a m by mi into bi ai plus dash. Okay, dash plus mr m by mr into br ar into ar. So this whole thing will become 0 as you refer to this equation. This m by mj into bj is concurrent to 0 mod mi. So once you fix I, so this will be concurrent to 0 mod mi, this will be concurrent to 0 mod mi using this relation, the whole thing, but except this one. By equation 3 we have m by mj into bj aj is concurrent to 0 aj mod mj. So instead of j you replace it by I, so m by mi into biai will be concurrent to ai mod mi. So this implies that x naught is concurrent to ai mod mi by equation 3. So x naught is a common solution, that is x naught is concurrent to a1 mod m1, x naught is concurrent to a2 mod m2, and so on. Or we can say that x naught is a solution of the linear concurrence. Next we show that if x naught, x1 are two common solutions of the concurrence, then x1 will be of the form x naught plus mk. So that is, if x naught is concurrent to a1 mod m1, x naught is concurrent to a2 mod m2 dash x naught is concurrent to ar mod mr, and at the same time x1 is also another solution, x1 concurrent to a1 mod m1, x1 concurrent to a2 mod m2 dash x1 concurrent to ar mod mr. So this implies that if you take the difference of these two, x1 minus x naught will be concurrent to a1 minus a1, that is 0, concurrent to 0 mod m1. So in general we have x1 minus x naught from this two is concurrent to 0 mod mi for I varies from 1 to r. Or we can say that you bring this x naught, or adding both side by x naught on this concurrences, on this concurrence we have x1 will be concurrent to x naught mod mi. So this implies that x will be concurrent, x1 concurrent to x naught mod m. Here we have mi and here we have my, because of this theorem from unit 1 on GCD, on LCM and GCD. Here there is a theorem by star. I'm using this we have here. If x is concurrent, x concurrent to y mod mi, we have here x1 is concurrent to x naught mod mi. Compare with this, if and only if x is concurrent to mod of LCM m1 m2 dash dash mr. So here also the same thing, x1 concurrent to x naught mod mi, if and only if, or it implies that x1 is concurrent to x naught mod of LCM of m1 m2 dash dash mr. And why here this LCM is nothing but m only? Why? Because since mi and mj, the GCD of mi and mj is conformed, that is they are relatively prime in pairs for I different from j, then LCM of M1, there is properties on GCD and LCM M1 M2 dash dash LCM. This notation stands for LCM square bracket MR will be equal to the product of all this M1 into M2 dash dash into MR, and we denote this product by M. So therefore, using this theorem, if it implies that from here it implies that x is concurrent to x naught mod m, where m here stands for the product of all this, and this is nothing but the LCM of m1 m2 mr. So from here it implies that, so as you can see from this relation, it implies that x1 concurrent to x1 concurrent to x naught mod m, by definition, if and only if if m divides x1 minus x naught, if and only if x1 minus x naught is equal to mk for some k, or if and only if x1 is equal to x naught plus mk. So if x naught is one such solution, then another solution will be of the form x naught plus mk for some k belong to Z. So this complete the proof. I hope it is clear to you, and remember that this is an important theorem. It used to come during annual exam, but in semester they used to ask states Chinese remainder theorem and solve the following system of linear concurrence, system of concurrences to find their solution. So that we'll discuss in the next class. Okay.